All right, so we did a case study and we found some inferential statistics on life expectancy. We're group 16 and I'm Michael Youngle.
My name is Alexander Jones.
I'm Caleb Humphrey.
I'm Leon
Elliot Jasicki.
And I'm Leon Juan.
So just a little bit about the Y variable that we take a look at. So what is life expectancy? So life expectancy is the average lifespan of a human being. It's an empirical metric, not unlike average height or average age. And determining factors of life expectancy are of considerable interest to politicians, economics, think tanks, etc. So some aspects of life expectancy. So life expectancy is generally higher in developed countries than developing countries. There is a consensus that BMI has a negative linear impact with life expectancy, with further increase for higher weight categories. There's dispute in the ability of infant/under 5 mortality or adult mortality to be able to determine life expectancy, since that is a result of mortality across all different age groups. Malnutrition could more heavily impact under 5 mortality than mortality of other age groups. And there is insufficient evidence on how alcohol consumption affects life expectancy overall. So the origin.
So the Global Health Observatory, or GHO, is a repository that is under the World Health Organization, and it keeps track of many related factors of human health status for all countries. The data set that we used for life expectancy was the health factors of 193 UN, or United Nations countries, from the years 2000 to 2015. And they all came from the Global Health Organization Observatory website. Just a thing of note is that the data set that we used was 2014, and explanation of data. So there were some incomplete sections of data, which led to removal of 11 of the countries, so we're down to 182. And then non-UN nations such as Kosovo and Taiwan are obviously not included. And then we did not like how the developed/developing categorical variables were used, so we changed that to make development status determined by HDI, where HDI of less than 0.8 means you are developing, and anything above that is developed. And then for income, we will be determined by GNI, which is GNI per capita instead of HDI. And due to incomplete data, certain countries, we will only be using 7 of the 28 predictor variables that were included. Additional explanation. So there was some missing data for the BMI of Sudan and South Sudan, as obviously Sudan has only been around since 2011, and therefore we needed to copy some of the demographics for South Sudan from Sudan, and that is what we did, and there was a website that helped us do that. These are the sources for our data. So we have the main source, which is the GHO, the data that we use for the HDI and GNI, and then data that we use for South Sudan and Sudan. General research question and full amount of parameters. So our general research question was, what societal/demographic factors are most worth considering to improve when trying to improve life expectancy? And so our X1 is income, our X2 is adult mortality, our X3 is alcohol, our X4 is BMI, our X5 is under 5 deaths, our X6 is total expenditure, and our X7 is development status, and our Y is life expectancy. Individual research questions and hypotheses. These will be touched on in future slides.
For question 1, we ask, does per capita alcohol consumption have a significant effect or not on life expectancy, not considering adult mortality and under 5 deaths mortality? Here we begin with the 3 plots to answer question 1 on the full model for question 1. This is the normal probability plot, the residual plot, and the variable plot. And what we see from our initial impressions here, there are no extreme points actually detected from Cook's distance from the influence plot. Only one point is moderate influence, and the variable plot does not indicate any major multicollinearity. Now, what we do see from the normal probability plot is that there is some deviation at the left tail. We must, however, engage in Box-Cox transformation because the Shapiro-Wilk test does actually yield a significant p-value. Furthermore, the residual plot does in fact show some non-constant and decreasing variance. We will proceed with WLS after the Box-Cox. Nothing else is determined to be needed. So we perform the Box-Cox transformation. Firstly, we yield a lambda of 2.87. We'll use 3 for our application. And we do see that the Box-Cox was successful at normalizing the data. We'll see the normal probability plot afterwards. However, we do not see any definitive changes in the residual plot, unfortunately. And furthermore, there's an attempt made at weighted least squares. We made 2 iterations. However, the residual plot does not show any definitive change at all. Here we provide the change of p-value in the Shapiro-Wilk test. We do see a great improvement. And furthermore, we also do see a modest improvement in the R-squared. Here we have the final plots of the transformed data after remediation. We also see an improvement, a severe improvement on the root MSE, very considerable improvement. Lastly, we will conclude with the F-test. Now we conduct the F-test with extra sum of squares to test our hypotheses. The results are down below underneath the model summary for the final model with improvement, with remediation and transformation. We yield a critical F value of 3.895, and thus we conclude that alcohol cannot be removed from a model with all continuous variables except for mortality rates. Some analysis. Alcohol consumption is worth consideration for understanding life expectancy. The positive beta for alcohol indicates that higher alcohol consumption is correlated with higher life expectancy. This does not prove causation, however. An important note is that unequal error variance in the final residual plot that we yield, even after transformation, does cast doubt on the validity usefulness of our finding. However, we do note that the test statistic is much larger than the critical value. Finally, we conclude with the cross-validation. We do see a small change of the root MSE. Earlier, it was 5.7 exact, so we do see a very small increase. Our interpretation of this is that the model will be slightly worse at modeling new data, which is to say data from new years, as compared to the data gathered, which is the year of 2014. However, this will not be by any considerable amount.
Question 2. Is there a difference in the linear impact between income and total expenditure on the average life expectancy? Here are the plots listed below. As you can see, there are many violations. The 2 most important violations that are seen in this slide is the normality violation and the constant variance violation. You can see that with both the QQ plot and the fitted residual plot on the right. One extreme point has been detected from the influence plot / Cook's distance, but there are no major multicollinearity detected from the plots. The deviation at the left and right tails, as well as part of the middle, is seen in the QQ plot. The Box-Cox remedy is used to try to remedy this deviation. And the residual plot does indeed show unequal variance. The lambda determined from the Box-Cox is 2.93, which in our case has been rounded up to 3 for simplicity. The normality probability plot is improved, yet the test still fails for the Shapiro-Wilk test for normality. The new p-value for that is 0.022, which is less than 0.05. We have no ability in the context of Stat 512 to provide any other additional remedy against the violation of normality. Therefore, we must conclude that the data is too non-normal to conduct a hypothesis test for this question. And we must be able to conduct tests for non-normal data or provide any other method to remedy against the violation of normality. The k-fold cross-validation notices a much higher increase in the RMSE, while also a small increase in the R squared. This means that this model will perform worse on new data than on the data provided.
All right, question 3. Alcohol consumption, BMI, and under 5 deaths. 3 plots. As you can see from our plots, we have a roughly normal QQ plot and a clear non-constant variance in our other plots. Initial impressions. Shapiro test initial value is 0.156, which is good news. Our data is clearly normal. No multicollinearity can be seen from our variable plots. However, we do see one extreme point in our influence plot. There is a clear non-constant variance, and we would take remedial action using box Cox or weighted least squares. In this case, we chose box Cox, and we will use weighted least squares if necessary. And there will be analysis / possible removal of the influential point if it is still present after remediation. Remediation and diagnostics. So our box Cox, we had a lambda of 3.33 or 3 1/3. We saw a genuine improvement of our error variance, and it was much more constant. Furthermore, our influential points disappeared after remediation, and our R squared value became slightly greater, and our root MSE improved from 5.59 to 3.6 times 10 to the negative 6. In conclusion for question 3, so we had a critical value for F of 2.44, and therefore it can be determined that development status does in fact have an effect on life expectancy when alcohol, BMI, and under 5 deaths are considered. Our BMI has a significant interaction effect of 0.007 as our p-value, and alcohol and under 5 deaths do not have a significant interaction, with 0.51 and 0.33 being their p-values respectively. Final report and conclusion continued. So from our analysis, we can determine that the BMI result can indicate that the diet is probably the most possible reason for less developed countries to have lower life expectancies, as they have more than likely an unhealthy diet. This result could indicate that also that under 5 deaths for developed countries are not a major concern for improvement as opposed to other factors, and alcohol consumption is a commonality among developing countries and developed countries, and thus any knowledge gained about healthiness of alcohol itself would have ramifications for both the developed and developing countries. Question 3, k-fold cross-validation. So we had a k value of 5, and we saw a slight increase in our root MSE, and therefore we can determine that this model will be slightly worse on new data when compared to the data that we had provided. So our 2014 model would not be as good for 2013 or 2015 respectively.
Including remarks for each question we have. For question 1, we needed to transform the data to meet the normality. Since the F value is larger than the critical value, we conclude that alcohol is significant when it comes to life expectancy, but also note that regular variance has to be taken into account. For question 2, after our remedies, normality could not be established, and we do not have the techniques to further analysis this data and transform it to the normality that we need. For question 3, we use the box Cox to solve the variance issue. Since the F value is larger than the critical value, we concluded that development status does have an effect on life expectancy when considering alcohol, BMI, in under 5 deaths. And then here's some sources that we use for data collection.